All right, good morning. So let's recall the chain rule. The chain rule basically says that if you have a function in a function, we can take a derivative of said functions by simply applying the chain rule. So we have our inside function and our outside function. So in this case, the inside function is g of x. It is the function inside f of x. So we have y equals f of u, where u is represented by g of x. So y is really f of g of x. And if I were to take those derivatives using my old rules, that would say y prime, which is dy dx, is equal to f prime, the outside derivative, keep the inside, times g prime of x. Well, g prime of x can be represented by du dx. And f prime of x can be represented by the derivative of y with respect to u, because the function f of u is with u. So hence where this comes from. And then we can see that the du's cancel and we get dy dx equals dy dx. That is why the chain rule is valid and true. So let's review some similar functions where you differentiate and when to use versus not use. So over on the left, we have y equals x squared plus 1. So this function is simply a quadratic. We can take the derivative of a quadratic easily enough. Now, over on the right, that quadratic function is now under the radical. By being under the radical, we now need the chain rule. Over on the left, we have y equals sine x. On the right, we have y equals sine x, but now it's a sec x. So the period of the function has changed, which means it will change the derivative because the angle has changed the period, which will change how the derivative operates. 3x plus 2 raised to the fifth is like writing that out 5 times. Therefore, on the right, it's really like a fifth powered function. So the derivative of a linear function becomes a constant, but the derivative of a fifth powered function becomes a quartic, hence the need, once again, for the chain rule. Over on the left, you have x plus tan x, but over on the right, we have x plus tan squared x in there. So once again, that changes the period, which changes the function, which calls for the chain rule. Now, the chain rule is really helpful for tables of values. So it says the values of two differentiable functions, f and g, along with their derivatives, are given in the table for several values of x. So you have h of x and g of x and f of x once again. So it asks us to find h prime of 2. So the first thing I'm going to do is get a general derivative of h prime x. So the derivative of h prime x is the outside times derivative of the inside. So it's f prime g of x times g prime x. Everywhere I have an x, I'm going to replace it with a 2. And then I'm going to apply the table rules. So g of 2 comes from here, so you go to g, and we go down to x is 2, so that's a 3. So this becomes f prime of 3 now times g prime 2. And then we're going to apply that one more time. So we go to the derivative of f. We go to 3. So that becomes a negative 1. We go to g prime. We go to 2. And that becomes a 3/2. So this becomes negative 3/2. Letter J. So j prime of x is equal to g prime f of x times f prime x. So j prime of 1 is equal to g prime of f of 1 times f prime of 1. So that becomes g prime of f of 1. So f of 1 is 5 times f prime 1. So g prime of 5 is negative 1/2. F prime of 1 is negative 1. So negative 1/2 times a negative 1 is a positive 1/2. And there you have how you apply derivatives of chain rules using tables. Let's look at another example doing the same thing with new values. So in this example, we have the graphs of f and g. So instead of a table, we have a graph. So we kind of have to create our own table by using information from the graph. So example number 1 says a of x is equal to f of g of x, b of x is equal to g of f of x, and c of x is equal to f of x. Find a of 1. So a prime would be equal to f prime g of x times g prime of x. So a prime of 1 would be equal to f prime of g of 1 times g prime of 1. So then you have f prime of, so g of 1, g is in red, so 1 is 2. So we get f prime of 2 times g prime of 1. So f prime of 2 represents the slope of f at 2. So we're going to look at f right here. At 2, our slope's coming from this part of the line. So what we're going to do is say, okay, what is the slope at that point? So here is 2. So it appears to be going down 1, 2, 3 over 1. And then similarly up 3, left 1. So my slope at f prime of 2 would be down 3 over 1, or negative 3. Now, at g prime of 1, here's my graph, here's 1. So the slope is coming from the red line. So at 1, it appears to be going up 1, 2 over 1, up 1, 2 over 1. The slope is 2. So then the slope of both of those would be negative 6. Okay, b of 5. So we're going to do the same thing. We're going to start by finding the derivative of b, which is g prime f of x times f of prime of x. Replace all x's with 5s. And then go to our graph, find f of 5 to start. So we're just going to go over and say, okay, when f is 5, we're at -3. So that's really like g prime of -3 times f prime of 5. So g prime of -3 is the slope of the function when g is -3. So that's going to come over here. So it appears it is going up 2 over 1, up 2 over 1. So our slope at g prime of -3 is 2. The slope at f prime of 5 is going to give me the slope at that point. So f prime of 5 is the slope over here. So here's my graph at 5. It is going up 1 and over 2. So that gives me a slope of 1/2. So 2 times 1/2 is 1. Letter C, we're looking for the derivative of c prime of 1. So c of x is equal to f of x. So that gives that c prime of x is equal to f prime f of x times f prime x. So c prime of 1 is equal to f prime of f of 1 times f prime of 1. So then I have f prime of f of 1. So f of 1 is 2. Times f prime 1. So at 2, we already said it was -3. The derivative at 1 is coming from that same line, so it's 9. Where x times f of x squared. So a prime of x is now a power rule. So it's the first times derivative of the second. So that's f prime of x squared times 2x. So first times derivative of the second plus the second times derivative of the first. Then we're going to find all of that at 1. So that gives me f prime of 1 times 2 plus f of 1. So f prime of 1 is 2. So that gives 2 times 2 plus f of 1, which is 1. So we get 5. And then let's look at the next example. So we want to find b of x. I don't know why it's being finicky. So here we go. Let's find b of x. So b prime is going to be the quotient rule. So again, you have hi-ho, so it's ho-de hi. So it's f of x times derivative of the top, so that's 1/2 g of x to the negative 1/2 times g prime of x. So ho-de hi minus hi, so square root of g of x, d-ho, so derivative of the denominator, f prime of x, all over denominator squared. So now we have b prime of 3. So you have f of 3 times 1/2 g of 3 to the negative 1/2 times g prime of 3 minus the square root of g of 3 times f prime of 3 all over f of 3 squared. So at this point, we're just going to plug in our numbers. So f of 3 is 3 times 1/2. G of 3 is equal to 4 to the negative 1/2 times g prime of 3, which is 2, minus the square root of g of 3, which is 4, times f prime of 3, which is 4, all over f of 3, which is 3, squared. So the square root of 4 is 2. So in this case, that square root's in our denominator. So it's kind of like 1/2 times 1/2, which is 1/4, times 2. So 1/4 times 2 is back to 1/2. So times 3 is 3/2. Minus the square root of 4, which is 2. So 2 times 4 is 8, all over 9. So 8 minus 3/2 would give us a negative 6.5, or if you wanted to keep it as a fraction, this is kind of like 16/2. So you get negative 13/2 over 9, and that's kind of like multiplying by 1/9, so that I can get my answer in terms of a fraction, which is negative 13 over 18. Which represents b prime of negative 3. And I'm realizing after I opened up the note guides that actually example letter C was supposed to be a -1. So we're going to go backwards, and I'm going to redo that problem for you so that we can do it with the actual values that were on your paper. So let's go redo this. We did it for 1. Now let's do it for -1. So we already said that c prime of x was equal to f prime f of x times f prime x. So now we're just going to change it. We're going to do -1 and f of -1 is 4. So then the derivative at 4 is up 1 over 2 times the derivative at -1, which is up 1 over 1. So now the answer is 1/2. Okay? So again, hopefully that helps. It helps you see exactly what we are doing, how we are doing it, and what the derivatives should look like using the chain rule and a table, because that is a key part to understanding the chain rule. All right, thanks guys.